Good evening, everyone.
Good evening, sir.
I hope you had a great day.
Thank you, sir.
Okay, so you can hear me clearly, right? So we'll give some time, maybe in the next 6 minutes, we'll start. This is 4 minutes past 8. So by 8:10, we'll start. But for the meantime, I would like you to get your uh, open your the R script and get ready, and make sure you can also open your RStudio while we get ready. Good evening, everyone, once again. Good evening, profs. Good evening, doctors. Good evening, everyone. We're just starting, and yesterday we're able to do number 2 descriptive statistics. We're able to do number 3. Can you hear me?
Yes, we
Hello.
can hear you. Yes,
Okay.
we can hear you.
Yesterday we're able to carry out the descriptive statistics analysis. We're able to do correlation and regression analysis. We're able to do chi-square and t-square. So today we are going to focus on analysis of variance, one-way ANOVA, two-way ANOVA, three-way ANOVA, split plot design. Then we are going to do time series analysis. Then we are also going to see how we can use artificial intelligence to carry out data analysis. Then at the same time, when we finish what we have for today, we'll go back again for what the analysis, all the analysis we did yesterday, we are going to repeat them today. So I would like us to pay attention, please. For me, because I've already given you the R script and what we did yesterday, some people, I believe they are fine with that because if you just follow what we did yesterday, just copy the script and put there with the explanation of what and while the script is written, by now, I think everybody's supposed to be fine with or confident with what we are doing. So don't wonder if some people are not able to join us today because I believe a lot of people told me that it's very simple that they were able to get through. There's even one person yesterday that he put a message that he was not carried along, but he kept calling me today and he was fine. He discovered that he made a mistake, so instead of saving the file the way it is, please, when you download the data sheet, save it with the same name. So what he did, he saved it with a different name. So that's why he was not able to follow through that yesterday. So, but he was able to correct himself and he was able to run all the analysis. So please, let's just pay attention so that let's see what we can achieve. And I really want to let you know that when we get to using artificial intelligence to carry out this data analysis, you may not even want to use R again. So let's just see how we can move ahead and proceed. Then we're going to come back to do the analysis we did yesterday. So now I will close my this screen now. Then I'll open my RStudio. So open your RStudio, download the data sheet, Nano 1, Nano 2, Nano 3, and save it the way it is. Nano 1, save it as Nano 1. Nano 2, save it as Nano 2. Because those are the names we use to write the code. If you must change the name of the data sheet, you must change the name on the code we are writing. Then also download that of moisture. So you are downloading Nano 1, datasheet Nano 1, Nano 2, Nano 3, and moisture. The moisture is for time series analysis. Are we together? Hello? Are we together?
Yes, sir, we are together, sir.
Thank you, thank you, thank you, thank you for responding. So I'll go over to go to search to open your RStudio. My RStudio is trying to open. Okay, my RStudio is open now. Okay, so the next thing we're going to do is we'll head over to that plus sign under file. We want to create another R script and we'll call it Hanover. Go to the plus sign under file, top left, you see a plus sign under file. Click on our script. Another one is created. Mine is created. So you can click on the save icon. Then you save it Hanover. Hanover. Okay, let me use small letters. Hanover. Okay. So I saved mine. So the next thing we're going to do now, we'll go to our script. So we'll copy from analysis of variance. We'll copy to the last thing before time series analysis. The last code before time series analysis. So we'll copy from analysis of variance to output 1 before time series analysis. Are we together?
Yes, we are.
We are
Okay,
together,
good.
but some point is like you are not audible.
Okay. Can you hear me now?
Yes, we can hear you.
Okay, good. Okay, good. Okay, good. All right. So, all right. Okay. You can hear me clearly now. Can you hear me clearly now?
Better now.
Okay, good, good. Thank you. But did you hear everything I said before?
Yes.
Okay,
You
good.
said
So we can proceed. Okay,
said
so
we should
copy
send
your
the R script workspace
yes,
as Hanover. And we've done that.
yes, copy from analysis of variance.
I think you're far from your mic or something.
Copy the from analysis of variance to output before time series analysis. Have you done that? I'm trying to do my own now. I hope you, yeah, are you seeing my screen? Can you see my screen? Are you seeing my screen?
Yes.
Okay, good, good. Okay, so I copy to the output.
I tried calling you now. I called you. I don't know what happened. The call was not going through.
Okay, please, can you mute? Hello, sir. Please, can you mute?
Maria.
So that you don't distract the class. Okay. Maria. I paste mine. Please, someone. Is it Professor Christopher, Dr. Christopher, Mr. Christopher? Please, can you mute?
I'll start my class.
Okay. Okay. So, have you all copied your R script? Please, someone talk to me. Hello. Oh God. Hello.
We have copied.
Okay, you've copied. Okay, now. Okay, so now let's import the data sheet. Nano one. Okay, so we go to the top right hand side, then we'll see import
I was
data.
calling you, see. Thing was not
Please,
correct.
Professor Christopher, Mr. Christopher, Dr. Christopher, please can you mute? Okay, so we are trying to import our data sheet now, Nano 1. So I head on to import data set, then from Excel. Okay, browse. Then where did I save it? My own is on desktop. So Nano 1. Okay. So mine is there already. So you import. Are we together? Are we together?
Yes, we are.
It's like it's only one person that is talking. Please, are we together? We
Yeah,
are
we
more
Yes,
than
we
we are
are.
almost close to 30 here. Okay, good, good. Okay, if you've done that, you've imported your data sheet. So the next thing we'll do, click on the ANOVA script, the one you just said. Okay, trying to adjust my screen. Okay, so now what is important now is we have to load the library. What we have the data package that we're going to use to run the ANOVA, the analysis of variance, which is what? The BAO research or Dubai research. Dubai research. So we head on to put your cursor at the edge of that at sign, then you run. Okay, mine I've already run. Mine is there. So my cursor is now at CRD. CRD. CRD, that is a complete randomized uh, design. Complete randomized design. So now if you look at our table we have treatment, nano fertilizer 0 mil, nano fertilizer 2 mil, nano fertilizer 4 mil, nano fertilizer 6 mil. That is the levels of nano fertilizer that was applied. Or those are the levels of nano fertilizer that was applied. Then we have replication, we have the yield data, then we have the pH of the soil, we have the nitrogen, we have the P value, the phosphorus. So now we head on to, we want to carry out, first of all, we are assuming that this experiment was not a field experiment, it was a greenhouse experiment. So in CRD, replication is not a factor. I hope we understand that. That is statistics. So now what we are going to do, let's try to understand what we are doing now. We see here line 4 as ANOVA, Fisher's least significant and Fisher's least significant difference. That is LSD. So we are using LSD to do our mean separation. Okay, I'd like you to also look at line 8, where you see, okay, let me explain you see output. This output, you can write anything, but I'm just using my own output 1. This output, this is the object. I understand this as the object. Then the object is assigned to this command. The function for CRD is CRD, bracket open, bracket close. Nano1 is the name of the file, name of the data sheet. 3 in bracket is the column for yield. Is the column for yield. Let's go back to our table. 1 treatment is column 1, replication is column 2, yield is column 3. Okay, are we together? Are we together?
Yes, sir.
Okay, good. So the next thing you see after the column, remember, please look at your screen. If I want to run everything, now I have a yield, I have pH, I have N, I have P. So I may decide to run everything. I can just say, okay, this is 3, this is 4, this is 5, this is 6. Okay, I can just do like this. I'll just put colon and put 6, and it will run everything for me. But let's start gradually. You'll see when we get to that. Okay, so now after that, you see a comma. After the comma, you see the file name again. Then you see the treatment. You know, replication, it's not a factor in CRD. Then you see 1. This one now stands for LSD. 2 stand for Duncan. 3 stand for HSD. Turkey's honestly significant difference. I think this is not so common with us here. I think what is common with us is Duncan and LSD. So now, after you've done this, this is the output. When you now run this output 1, you see your result in the console. So we can now put this thing on 4, your cursor on line 4, then run. Okay, okay, my answer is there already. So he has given me his console there. So the first thing we are looking for is the ANOVA table. Are we together? My ANOVA table, okay, the ANOVA table is already there in the console, which you can copy it and put in your document in Word. You can just copy it straight away and put it, okay? So you just highlight, you can just highlight like this and copy. Everything will copy, no challenge. Okay, so now you can see my degree of freedom. You see sum of square, see means, sum of square, see the A value, see the probability. So here, the treatment is there is significant difference among the treatment. You can see you can see 0.000000000502. So you can see it's highly significant. So now you go down. When you go down, you see some parameters there. You see the error, standard error of mean, then standard ESD, and SED and SEM, that is standard error of mean. So it depends on the one you want to pick and the one you use. You see the mean square error there, the degree of freedom, the mean, the what do you call it? Coefficient of variation. I think that's what they call it, the CV. The T value, the LSD value is there. Then you see the mean separation. This is the main separation. So meaning that the 4 mil nano fertilizer applied at 4 mil gave the best result, while the least was the control, 0 mil. Okay, so I will not do much of this interpretation so that we can, move fast. So let's see how we can. Now we want to run for RCBD. Now we are assuming that the okay, let's do for Duncan first. The next one is for Duncan. Let's run it and see what happens. So I don't know whether your own is on 10. So place your cursor on 10, then run. That is for Duncan. The first one we did is for LSD. Okay, so I run my own. Okay, the result is there. So you can see there's no difference, but this time around, it's going to give you, I think, some more parameters because you are using Duncan. So, but now let's move over to RCBD. You know, RCBD, that is a randomized complete block design. Replication here is a factor. So now you see this is the function. This is the function, RCBD function, RCBD. Okay, this is the file name, and this is the column we're analyzing the yield. Then this is treatment, and this is replication because replication is a factor. So let's run it now. Okay, good. So we have it here. So everything is there. We have our, look at our this thing, our ANOVA table, look at replication, look at the treatment, and look at the residuals. Look at the p-value. So they are all significant. Even the block is also significant. That's the replication is significant. So now I believe we are together. So we move over to factorial experiment. This is a factorial experiment laid in CRD. That is factorial experiment laid in complete randomized design. That is when you are doing a screenhouse experiment, whether screenhouse or greenhouse experiment. So we are done with that data set, nano one. So for me, I'll remove my own. So now we want to import data set nano 2. Nano 2. So I get to import data set, then from Excel, then browse. My own is on desktop, then nano 2. Okay, the data is already there. Then I import. Are we together? Are we following?
Yes, sir.
Okay,
Yes,
good,
sir.
good. So now we are on FCRD, FCRD, FCRD. Now look at our data set. Now our data set, what does it mean? When you have more than one factor, they call it factorial experiment. When you have more than one factor, we call it what? A factorial experiment. So now here we have variety. Tailor maize, that's the GMO maize. Then we have Stamex. Okay, you can scroll down to look at it. We have Stamex 62. I think it's one of the highly yield high yield maize. Then we have DK 920. So this variety, these varieties, these are varieties of maize. Then we still have our fertilizer application, nano fertilizer, 0 mil, 4 mil. Okay. Then replication is there. Then our data remains. Okay. So now let's head over to FCRD. So we want to run now, you know, because it's a controlled experiment, it's a screener's experiment. Here, replication is not a factor. But this time around, we are running from 4, all the dependent variables. We are running the analysis on all the dependent variables, the yield, the N, the P, the pH, okay? So we run. And remember, today, we are doing Duncan. So that's what we have today. So mine is already done. Let's look at this is the ANOVA table. Factor 1. What is factor 1? Factor 1 is the variety. Factor B is the fertilizer. So you can see the degree of freedom, see everything there. Look at the p-value there. Look at all the standard errors for the main effect and for the main effect, and also for the what do you call it? Interaction effect. Okay, the CV is there, the means. Okay, now this is the main effect. This is the main effect. The what do you call it? Multiple comparison. That is means separation for the main effect. This is for variety. We have DK 920 Taylor. So there's no significant difference because the letters are the same from the ranking here. So then this is for okay. This is for the main effect for the fertilizer. Why? This is the interactive effect or interaction effect. I don't know what you call it. Interactive effect of the both. Look at the one that gave the highest result is DK 920 and nano fertilizer at 6 mil. So that's the one that gave the highest distance, the highest result. So I think we can proceed. Okay. Now let's do a factorial experiment laid in RCBD. So here, replication is a factor. Replication is the block. It's blocking because it's a field experiment. So now this is the function. This is the function FRBD. Two factors, because we have the two factors. We have the variety. Look at the variety, and we have fertilizer. Then we are using Duncan. That's why there's 2 here. And we have also replication as a factor. Okay, so let's see how we can run it. Okay. So we have a result. So the ANOVA table is there. Then this is the interaction effect. Okay. Are we together?
Yes, we are together. I'm following you.
Okay, good. Okay, we are forcing ahead. Okay, so now we can move over to split plot design. A split plot design, it's a kind of it's called it, the right name for it.
Excuse me, sir, please.
Okay.
At the FRCBD, you said we have 2 factors. That's why we have the nano 2. 4, and you said replication.
No. Listen, that's nano 2 is the file. We just named the file nano 2. The function is this is what is important. This nano 2, you can change it to your file name, anything. Like for instance, now if you
No,
change
no.
this,
Where I'm talking about is FRBD, two factor. Does that two represent the number of factor we have?
which two? If
After output one, under FRCBD, we have
okay,
output one.
FRCBD. Now,
Yes. Now
yes.
we have FRBD,
Look at
two facts.
listen. Can you listen? Listen first. Okay, we have FRBD two as a function. Can you see my screen?
Yes, yes.
Okay, you have FRBD. This is the function. This is what is most important. This one is a variable. It can change. All
No,
these
my
can
question
change.
is that variable, that two
Yes.
before the fact, does it represent the number of factor we have?
Yes, that's what it means. Two factors. It means two factors.
But in this case, replication is a factor, variety
Yes,
is a factor,
replication is a
and
factor. Yes, hold on. Replication is a factor. Hmm?
okay,
But it is called blocking. You know why we call it blocking?
okay,
Because there are variations in field. But you know, when you get to this table, look at this table. The only main factor we have, the three main factors we have are what? Variety and fertilizer.
okay, okay,
You understand?
okay,
Replication is for precision of the precision and
okay,
accuracy.
okay. I understand now. I understand.
Okay, good. Okay, all right. Okay, so let's move on to split plot design. In split plot design, you know we have the main plot and we have the subplot. Is that correct? Hello, that
Yes,
is
your question again.
statistics. We have the main plot, then we have the subplot. So
Yes.
in split plot design, we have two major factors. We have the main plot and then we have the subplot. But what some people do, some people will have three factors. They can have location, they can have variety, and they can have fertilizer application. Then what they do, they will mix fertilizer application and variety as subplot. Then why location is the main plot. But for me, that is not a good way to do. It's better we keep our research simple because when we complicate our research, it becomes difficult for us to interpret the result accurately. So let's um, see what we can do now. So we are still using this. We are still using the same data set. So what we have here, this is the split plot function. The same name of the data set. Then in split plot design, replication is also a factor because it's a factor because split plot design is always carried out on the field. It's not a greenhouse experiment. It's a field experiment. It's not a controlled experiment. And even it's a field experiment. That's the right way. So let's see how we can carry out the split plot analysis. Okay, so let's run. Okay, my own is there. Let's go to the ANOVA table. Okay, you can see the main plot. What is the main plot? The main plot is the variety. Then the subplot is the fertilizer. You can see all the p-value here. Level of significance that you may want to choose. You can choose anyone to report. Then this is the main. This is the main plot effect. No significant difference. This is the subplot effect. There are a lot of significant difference. Then this is the interaction effect. Okay. Are we together?
Yes, we are together.
Okay, good. So now we are going
Sorry,
to
Mr. Andy, I need some clarification, please.
go ahead.
Sorry, I was not able to be consistent because of network. For
Okay.
this split plot, I just wanted to run now, but each time I run, I will see error
Okay, you copy
that
the what?
could not find function split plot.
Okay, there's a problem with what you copy. Check what you copy. There's a mistake somewhere. It's not supposed to give you error. Just check the spellings. Check there was no mistake anywhere.
But I copied it exactly from where I downloaded it down.
Sir, if I may want to add to that, I had similar error, but I discovered that I did not run my library. Before you can run ANOVA, you have to run your library. That means you have to run that first one, library DOB research. You have to run it first.
Okay, good.
You have to activate it first.
That's
Thank
a good
you
one.
so
That's
much.
a good one. Okay.
Thank you.
She didn't join us on time.
Yes, actually, because I had network issue.
Oh, sorry about that. So please go and run that. Run from the first, start from the beginning. I just run everything.
Thank you so much.
All right.
Mr. Andy, please, I have a question to ask before we continue.
Go ahead.
Where you have we are in split plot now. We have nano 2 bracket 4 and 7. Please, I do not understand what 4 and that 7 stands for.
Okay, 4 is okay. Go to the table. Let's go to the table. Now,
okay.
I explained it before. Maybe I didn't hear me. If you count variety 1, column 1, fertilizer column 2, replication column 3, yield is in column 4. Yes, 5 is called is pH. N is 6 is N. Then P is 5. So we want to run everything. That's why we are saying 4 to 7. Do you understand now?
1, 2, 3, 4, 5, 6, 7. Okay. So we are starting from 4,
yes,
which is the yield.
4 to 7.
Then we run it to 7, which is the P.
It's only those are dependent variable. The yield are dependent variable. The pH dependent variable.
Thank you.
You understand it now?
Thank you. Yes.
Okay, good. Okay, so can we proceed?
Yes, sir.
Okay, good. Okay, so now remove the data sheet and put nano 3. Import nano 3 now. Nano 3. Mine is there already. Okay, so on nano 3, the data sheet, we have location. Kaduna. We have Kaduna. We have Delta, Kaduna and Delta. Okay, we have only 2 locations. Then we have variety. We have DK 920, SAMES 62. Then we have Teller. Okay. So on fertilizer, the same level of nano fertilizer. Then we have the replication. Then we have the yield. Here we are only looking at the yield. So let's head on to our nano script. I mean our R script, ANOVA script. So now we have 3 factors. So now this first one, we have what people will call that will be 2 by 3 by 3. Is that correct? 2 by 3 by 3 factorial experiment. Okay, the first one is that laid in CRD. Remember, that is basics of statistics. Okay, So laid in CRD. So let's see how we can run the first one. Then the second one is for RSCBD, where replication blocking is important. But here, blocking is not important. We only have the three factors. Okay, so let's run it and see. Okay, so I run mine. So I'm already getting my results. This is the interaction effects. And the main effects are the ANOVA, this thing. Are we together?
Yes, we are together.
Okay, good. Okay, so now can we move ahead to run the one for factorial experiment 2 by I think the way you will put it is 2 by 3 by 3 factorial experiment laid in RCBD. So now that's what we are running now. We have three factors. 1, 2, 3. Okay. So we run it. Please, if you have any question, you can ask. My own is already there. I finished my own already. Any question? Are we following? Please, are we together?
We are following, yes.
Oh, good, 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 good. So now we are done with see, if you have you are carrying out the experiment, if you check most publications, you see research papers in Africa, that is where you see where they have three factors experiment. In most researches in advanced world, you will never see more than two factors. So sometimes we complicate matters here. So please, let's see how we can always simplify our research so that the result can be very useful. Okay, so for me, I'll remove my data. So the next thing we are going to do now, we are going to go back to under file. We create another R script. Mine is already created. So what we are going to do,
please.
I'm going to question.
Yes, sir.
Okay, go ahead.
I've observed that each time you finish with one Excel file, you remove it before putting another. Does it have implication if you have to load two Excel files, maybe nano one?
No. It doesn't have any implication, but because I don't want to be confused.
All right. Thank you, sir.
Yes, I don't want to be confused. It doesn't have any implication, but it's always best you remove it. The best is you remove it. Is that okay? Just to simplify things, just to make things simple, you remove it. Okay. So I want to save my R script now as time series. Time series. Okay. So I've saved mine as time series. So you head on to the script now, copy for time series analysis. Copy the code for time series analysis and paste them. My system, as I Can you hear me now?
Yes, we can hear you, sir.
Okay, sorry about that. I didn't know I was thrown out. I was thrown out. I didn't know. So for me, I've copied my time series analysis script to my R script. Okay, let me take it up. Okay, I've copied it to my R script. Then I've also imported my moisture, the data sheet moisture. You have number one there. You have January 2023 to October 2025. Then the second column there, you have soil moisture. So what we are trying to do, we are trying to take the differences, the changes in soil moisture throughout this period, so that we can predict for the next 1 year what the soil moisture will be like. Are we together?
Yes, we are together.
Okay, good. Okay, so now I hope, have you copied your time series script?
We have copied and pasted.
Okay, good, good. So now, so let's run the packages. I mean, let's load the packages. Library focus, library time series, library ggplot2, library STS, and Zoom. Okay, let's run them now. Okay, they are all loaded now. So the next thing now we are going to do, we are going to create what? A time series object. I've told you anytime you see this sign, it means what is here is object. Okay, so this is the time series function. TS, small letter TS is the time series function.
Please,
Remember,
your audio is not audible. I think your audio device is far from you.
okay, but can you hear me now? Can you hear
yes,
me now?
better now. Yes.
Okay, good, good, thank you. So I say this is the object. This is assignment sign. This is TS. TS is the function of time series. TS, small letter TS. This is the name of our data sheet. This is soil moisture is the dependent variable. This is the variable. This is the variable. Then we have another function here. C. Then we have start. Where did we start from? We started from January 2003. So this is where we start from. Okay. So a frequency is 12 months. We have 12 months in a year. Is that okay? Okay. So the next thing you see is, after that, you see visualize the data to identify trends, seasonality, and any usual patterns. So this way we are going to do a plot with that object we created. Then we are also going to decompose time series. What that means is that we separate the time series into trends and seasons. You will see it when we plot it. So then we build a model. So we are using this auto regressive integrated moving average to build a model. That's the model we are using to build this is what we are using to create the model that we use to predict the the data, the forecast the data. Okay, so then we have forecast for 12 months ahead. So this is the forecast function. This is the object. This is the forecast function that we are going to use to do the forecast. This H now means we are forecasting it for the next 12 months. H means what? H, that's for the next 12 months. So we are going to plot, and we are going to plot to see how it looks like. Then the next thing we'll do, we'll make sure that we have it export to Excel CSV file so that we can look at it. So let's head to line 7, then we run.
Sorry, sir. I think your cursor is not moving. I don't know if someone else is not moving. So I can't
maybe
really
your
follow
own
your
is freeze,
movement.
but line 7, after you put your cursor at create a time series object, put your cursor there. Can you see it there? Can you see that line? For my
yes,
own,
I can see line 7. Yes.
For my own is line 7. I don't know what is it for you, depending on how you copied it. So
no. My point is your cursor. You know, when you're moving on your screen, your cursor is supposed to move, and I am supposed to see your cursor moving on your screen.
Okay, but can you see my screen?
I can see your screen, but your cursor is not moving. Your cursor is just one place.
No, I can't see your screen, please.
You can't see my screen?
I think there's a problem from your side.
I can't see your screen.
You cannot see my screen?
The screen is there, but the cursor is not there.
I can see your screen, but the cursor is not moving.
The cursor is not there.
Okay. Let me share. I'll stop sharing and
Stop
share
sharing
again.
and share again. Yes.
Okay, so I'll do that now. So I'm sharing again. Can you see it now?
Better. Your cursor is moving now. That's good.
Okay, good. Okay, so I put it on 7. Then we run. Then we run. Okay. Okay, let's plot. Okay, now we can see. Okay, let me remove this thing. We can see the plot over here. You can zoom it. You can see this is the moisture, and this is the time. So, okay. Maybe if you are not conversant with time series analysis, maybe you have to read about it, but let's just do the analysis. So mine is on line 11 now. So I run again to decompose. Okay, now, so I've been able to decompose those seasons. I zoom again. So this is the plot. Now you can see this is random, this is seasonal, this is the trend, and this is the observed. So you can take a look at that. Please, if you are not conversant with time series analysis, you have to maybe look at it, study it. It's very, very interesting if you understand it and if you can use it for your publication. And you can also use it to create early warning system models. It's fine. It's fine. Okay. So put on then okay, what I'm looking for now, okay, I plot, then I'm doing forecasting now. Let me zoom it so that we can see. So now I've been able to forecast 2026. This is the shape, this is the moisture content for 2026. This is the moisture content for 2026 for the next 12 months. You know, we stop at October. So this one is starting from November 2025 to September, right? September, it should be September 2026. 6. We'll see it clearly because when we export the sheet, we'll see it clearly. Okay, now so let's run and export the sheet. Okay, someone is raising the hand. Go ahead, please. Go ahead, please. You are raising your hand. Okay. All right, so let's run from 20.
Sorry, I was trying to unmute myself.
Okay.
I ran the line 7. And when I plotted, I didn't see anything. I don't know whether there's something I didn't get right.
No, by your you can only see by your left, what do you call it, your right, the down side. Right,
the console or
no, it's not console, the one opposite console by your right hand side.
Yes, that's what I'm saying. The plots now, when you plot.
Okay, you didn't see anything there.
Plotted yet.
Yes,
okay,
I didn't
please
see anything.
run it. You've not plotted yet. Just run it.
You've not plotted, so you have to run line 10. Run line 10. You will see it.
Yes. Run it. Yeah, just keep running then. Yeah. We are actually on line 20 now. So let's run 20 and you can see what we have there. So it's giving you what this. So I've forgotten how to explain this to you, but people that are familiar with this, I don't know. Is anyone familiar with time series analysis here? Okay, good. So what is important to me is to get the focus. So which I run the last line, then I have the focus in my system. So go to search. Can you see my cursor? Go to where they write the type here to search. So I will search. What I will search for will be focus. If I search focus, I will see. So can you see my screen?
Yes, we can see it.
Okay, so my own is already open. So the focus has been done. So the focus is from November 2025 to October 2026. Okay, let me enlarge it so that we can see it clearly. Okay, so and this is the point focus. This is the point focus. This is the 80% confidence low, 80% confidence high, 95% confidence low, 95% confidence high. So for this is the focus, this is the point focus for my figures. These are the focus figures. Have you been able to get this Excel sheet?
Yes, sir.
Can you get?
Yes, sir.
Okay, we are together, right?
Yes, sir.
Okay, good.
No, please. Where did you get the Excel?
Go to search, type. Go to your down this thing where you search the system. Search focus. You see it come up there. You click on it and open it. Are we together?
Yes, sir. Yeah.
Okay, good.
I didn't get my own. You said we go to where we search on our system, right?
Search where you see type after the window sign.
Yes. Type and search. I type and change focus, but my own is not coming out.
That means you didn't run it complete. Run it down. Run everything. Run the line 21 down.
Yeah, okay. If you do, I got
the moment you run, you will see. Please, I want us to be fast a little bit so that we can, we still have to do what we did yesterday. The analysis we did yesterday, we have to repeat them. So now, do we have any question? Because I want us to go to we are going to now.
To copy of these graphs and plots and place it in a Word document. How do we go about it?
Just do highlight, put your cursor highlight on the console, all the results. Or just do like this. Can you see my screen? Can you see my screen? Are you seeing my screen?
Yes, sir. We can see your screen, sir.
Yes, just highlight and Control C. Highlight, Control C. Is that okay? If you just okay, thank you.
Okay, sir, you can continue.
Okay.
Sir, I have a question, sir.
Okay, go ahead.
Regarding the graphs, how can we export just the way you export the CSV file now for that of the soil moisture forecast?
No. This, no. Look at my. Can you see my cursor?
Yes, sir.
Yes, click on.
Okay, export right there. Yeah, I can see it. I can see that.
PDF. How you can even copy it if you want to copy it. Is that okay?
Okay, I've seen it.
Okay,
thank you very much, sir.
Please let's head on to artificial intelligence, AI. Okay, now we are on Google now. Go to Google. Are you there? So type Julius AI. Julius is spelled JULIUS.AI. Julius AI.
Hello, sir. Are we going? I'm lost here.
Go to Google. Go to browser. Your Google. Browser. Your Google. Are you using Chrome? Which one are you using? Just type Julius.ai. Are you there?
Yes, we are with you.
Okay, good. So enter. So now my own open like this because I have signed in already. I already have account already. But if you don't have account, so what you see is scroll down and click on try for free, something like that. Try for free. You see something like that. You click on it or you sign up. Are we together? Are we together?
Yes, sir. We're together, sir.
We're together.
Okay, sign up. Just put your email.
To sign up.
Put your email, put the password, and let's go. But just click on try for free, something like that. I've forgotten what will be there because my one I'm already in. I'm already signed. I've been using it, so it takes me straight to my account. Are we there? Okay, let me give you some time. Maybe in the next 2 minutes, we're supposed to get that done. Okay. Meanwhile, while you are...
We are with you, sir. You can go ahead.
Okay. Let me just let you understand. Julius AI is powered by so many large language models like ChatGPT, like Claude, like Google Gemini. I think those are the major ones that power Julius AI. So it's Julius AI uses natural language, just like English. So if you type English, you will understand. So basically, I have to tell you at this point, for more than a year, I've not used R to do any data analysis. I use this Julius AI to carry out data analysis. And I train business leaders how to use.
Your audio system is low, sir.
Okay, can you hear me now?
Better.
Okay, so I was trying to say while we are signing in or trying to sign up, I was trying to tell you that for a year now, I've not used RStudio to carry out any analysis. What I use is this Julius AI. So I also I train business leaders how to use this AI tool. Most importantly, I train them on how to use AI tools as uh, thought partners, and they use how to use AI tools for strategic decision making to make market forecasts and predictions and data analysis. And I tell you, it's actually worth doing. Yeah, they pay me 300,000 naira per hour to train them on that. And because they are getting real results and it's solving real business problems. So if you understand this AI, the services I render to them now is called prompt engineering. So what I teach them is what prompt engineering, how to write uh, something, questions, and how to get AI to ask them questions to get insight into the problems, their business problems, so that they can AI can provide a solution for them. So that's basically what I do. So let's head on to, I believe we are all here. Have you gotten to this point? Have you signed in?
Yes, we have gotten to this point.
So the next thing we do, attach the file. Have you seen attach file? Okay, before we do that, you see my email is there. Your email will also be there. What you have, okay, let me do something so that okay. Let me Julius. Okay, now good. Now I want you to understand what Julius AI can do.
Hello, sir.
Yes.
Hello.
Yes, go ahead.
I just signed in, and he's
Go ahead,
saying,
please.
how do I want to start the analysis? That's signing in
Just be there.
into
Wait for us. Just
Julius
wait
AI.
for us. Just wait for us. Wait for us. Okay, yes, respond. Keep responding. You know how to sign in stuff now. Just keep responding until you get to where we are. Okay, so I'm trying to tell you what Julius AI can do. It's used for data science. It's used for marketing. It's used for these RAVE OPS. Used for product finance, scientific research. I think this is the one that concerns us, education. So, and you can see here, Julius AI, they have the free version and they also have a paid version. The free version is limited. So let's head on to what we have to do.
Hello, Dr. Andy.
Yes, yes.
Hello. As part of
Yes.
signing in, they are asking us how do we plan to use Julius?
Yes, yes. Keep answering the question until you get to where I am now. Just answer whatever you want to.
Okay.
They will give you option. Yes, just answer. Keep answering them. It's just
Okay.
like when you want to. Yes,
Okay, okay.
education. Yes,
Okay.
yes. Just keep answering them till you get to this point.
Thank you.
When you get to this point, let me know. Are we together?
Moses, please mute your mic. Moses, please mute yourself.
Sorry.
Are we together? Are we together?
Yes.
Okay, now what the thing will do?
Yes.
Okay, good. Now, if you look at, you see attached button, attached icon there. You see connectors, you see tools. Some of these functions, you cannot use them until you pay, until you upgrade. But what we are to do is something that we can do with the free version. So the first thing we'll do is we attach our file. So the one we are attaching now is the Nano one. Let's attach Nano one. That Excel sheet, Nano one. Upload. You click, you upload, look for the sheet where you save it. Nano one. Nano one. Are we together? Mine is attached.
Yes, mine is attached too.
Okay, good. Good. Okay, so the next thing we're going to do, we'll ask AI. You know, we're just writing simple English. We'll ask AI, can you summarize, the attached data sheet? Enter. Okay, you can see he has done the summary for us. Can you see it?
We can see
Hello,
it.
you can
Yes.
see it. Okay,
Yes.
so the next thing you will do is, can you generate descriptive statistics? Descriptive statistics, though he has already generated. We don't need to ask the question again because it's already there. Okay, let's move ahead. Let's tell him to, okay, let's tell him to do an over for us. Can you please just be following the way I'm doing it? Can you do one way ANOVA for all the dependent variables Yes. Now, there's something I forgot to tell you. Everybody, go to the, have you seen where it's written connected? Connected.
Yes.
Okay, now, if after connected, you see something like this. Click on, you see R, you see Python. So click on R. You see Python, you see R, you see lane Python. So click on, we are using R. So click on R, okay? So I forgot to tell you that. So let's go back to our code, our writing. Can you do one way ANOVA for all the dependent variables and, okay, sorry, and multiple comparison I'm taking it easy so that you can follow using Duncan's uh, Duncan's multiple okay, should be Duncan's new multiple range test. I think that's the name. Test. Now we are trying to explain some things for the AI. You can explain that treatment is a variable, is independent variable. The yield, the pH, the N, and the P are dependent variable. So, but we can as well skip that. AI will know. So now let's export, tell AI to export it in Excel, the result in Excel. Export the result. Export the result to a single Excel file for me. Okay, so let's run it and see. If my own doesn't run, know that my free credit has elapsed because I've been using it. So for your own should run, your own should come up. I think it's running now.
My own has run.
Okay. So has it brought out the result?
Has given me the result. Aha.
Okay, good. So now click on the file he has given you. It's still running. My mind is still running. Mine is still running. So if he has finished, I don't know, it's not supposed to take time. I don't know, maybe my free credit is finished. So you can, when after getting the result, you can ask, can you interpret the result for me? If your one has finished. What is going on? Are we together?
Yes, we are with you.
My own has gone out of trying to. Okay. Look at what's going on. Then they are telling me to, okay, upgrade for a better model. Okay. No. What is
Does this Julius AI have a special feature to ChatGPT?
Yes, it's connected to ChatGPT. Okay, let me show you. If you go to default, I've said it before, it's powered by ChatGPT. Go to default.
Okay.
Go to default by your, you see where they write default, by your right hand side. You see ChatGPT 5.1, ChatGPT 5.1, Claude 4.5, Gemini 3. They but leave it at default. So my own, I just encountered a problem. So I attach again. Nano one. But I hope you are able to get the result, right? Are you able to get the Excel file?
Yes,
Yes,
I was
sir.
able to get the Excel file.
Okay, good, good. Okay, good. So that is how to, have you opened it? Have you seen those ANOVA tables?
Yes.
Okay, good, good. That's fine. So for me, you can go back and write, interpret the result for me on the chart.
Just simple, can you interpret the result for me? Just like
Hey,
that.
can you interpret the result for me? Then when it interpret for you, you can just copy it and go and paste. That is as simple as that. So with this one, you don't need to use RStudio again. You don't use R again. And basically, you can do like up to like 10 data analysis in a month for free version. You don't need to subscribe. But when you subscribe, you can do as many as you can. Look at here. If you subscribe $16 per month, it's not expensive. My own just expired last month. I subscribed. I just expired last month. So you can subscribe if you want to do more analysis. But for me, using this Genius AI, you can use it for any kind of analysis that you want to do. Just attach your file. You can see it was running R code. So it's the same thing as using R. So you don't need to stress yourself to use RStudio. Artificial intelligence, like I told you in the first game, AI is the end thing. We need to learn how to use AI. You can see even Nigerian government has introduced AI in the university. We now have BSc Artificial Intelligence. I think NUC just introduced. So AI has come to stay. And ability to communicate with AI will become very crucial in you being relevant in the scheme of things in few years to come. It's already happening in advanced country, but we are always reactive to things. 10 years, more than 10 years ago, that's when India and some other countries started their studies, and universities started offering courses on artificial intelligence. But now we are just starting. So please, you need to get acquainted with this. With this one, you don't need to use RStudio. Okay, so like I promised, we have to get back to see how we can do what we did yesterday. Is that okay? Are we together?
Yes, sir.
Okay, so I promise we are going to repeat what we did yesterday. So I will remove, I'll go to descriptive statistics. Okay. I'll go to descriptive statistics.
Sorry, you know what I did?
Hello? Hello?
After loading the data, I just asked it to do descriptive analysis, and it just did everything. The one, I don't know, even asked me.
That's it.
He even gave me interpretation. Everything is there.
That's it. I see you can get everything. It's very wonderful. See, I've told you for the past 1 year, I don't touch RStudio. I don't touch R and RStudio. I've been using Julius AI.
There are plots, diagrams, and all those. It's very interesting.
You can use it to plot. Okay, just ask, can you generate bar chart with treatment on x-axis and yield on y-axis? Type that. Can you generate bar chart with treatment on the x-axis and yield?
This one, he has done box plots. He has done all those.
Thank God.
Okay.
Thank God. Okay, it's fine. So do we still need to do what we did yesterday again?
But sorry, sir. This AI thing is really gonna make us lazy. Because if I want to go with AI, I mean I'll not know R again.
Are we tired or do we see? But sir, you need to master AI. I'm being very honest. You need to master AI. Sir, even I don't know whether you are a lecturer, I don't know where you are working. AI is going to disrupt all the industries. It's going to change things. AI will become like when a computer was introduced to the world. I mean, if you don't want to be literate in AI, you'll be left behind. So you have to learn to use ChatGPT to do things. And one funny thing is that there's something that is called prompt engineering. With prompt engineering, see, it's not just about asking AI something as Google. No, as you are asking Google, no. You have to learn how to ask AI to get good results. See, you can even use AI to write research paper clean, and nobody will know. You will pass through every form of plagiarism or whatever that you have. I can show you how to do that. So AI has come to stay. You can use AI to do anything you want to do. And if you are not using AI, you'll be left behind. So let's see how we can use the tools. Like the AI that is very good for research is called Perplexity. Perplexity. Claude is also good. ChatGPT 5.1 is also good. Hello, are we together?
We are together. I'm listening. Perplexity.
So,
I have interest in that.
okay, so can we repeat what we did yesterday, the analysis? Do we still have interest in RStudio? For me, I don't use it. You waste my time. I just go to AI and get my results.
Yes, I will still need the one of yesterday. Thank you.
Okay, we should do it.
Yes, please.
Okay, good. Okay, let's so I'm already there. Okay, so let's import our data. Go to import data set, go to Excel. We're importing soil in. Soil in. We'll do it wherever we can stop, we stop. You know, we are.
Sir, I think today we are finishing up. But
Yes.
I saw your spatial analysis. Are we still going to do that today?
Which one? No. That one is not part of. No. We are not doing that. The spatial analysis. That is
okay.
That one involves GI.
I have a question concerning that. We can use R. Can we use R to generate a map?
Yes, you can do that. You can use that, but you can as well use Julius AI to do that.
Okay.
My system has. Okay. Okay, so I'm trying to load. Okay, so my data is already there. Please, for people that are following up for what we did yesterday, please, let's pay attention. I've imported my data. So what we want to do now is descriptive statistics. So we'll start from the first thing we'll do. We'll load, okay. I think we've already done that. We don't need to do that because we can import data. So we don't need to load, read Excel. So we just put on line 3, descriptive statistics. So now, like I said, the mean there is the function. Then soil n is your data name. Then nitrogen is the parameter that we have it here. This is the data. We have nitrogen, we have carbon, we have pH, we have crops. So I mean, I expect. Hello.
Excuse me, sir. Yes, sir. Please, what file?
Soil in. Make sure it is safe soil in. Soil in. Are you there? Hello.
Yes, sir, I'm here. I can hear you.
Can you see your soil in, your data?
I'm here. I'm following through. Thank you.
Okay. So import, let's go. When you are ready, let me know.
I'm okay. I'm ready.
Okay, now, so let's run it. Like I said, the mean day is the function, median is the function, SD is the function for standard deviation, variance, VAR, max is for maximum value, minimum value, range, summary. Summary will give you the descriptive statistics. Then this one will give you for all the parameters. Then this is for carbon. You can do for pH, it's something you can try out. So let's run. Put on 3 and run. Mine is running, keep running. keep running, keep running, keep running, keep running, keep running. So I finished running that. So the next thing I want to do now, I want to plot bar chart. So the function for bar chart, okay, we've already done this. We've already loaded GGP, plot 2. So the next thing, we'll just go to the line 16. Then this is the bar plot function. This is the sort n. Sort n is the data name. This is nitrogen, where what we are concerned about is the nitrogen. This is the x. This is the name for the x-axis, which is the location. Then this one is the species between. Let me close this so that. Okay, now that place is clear. So this is the species for the chart. Okay, this is main is the title of the graph. Then the label for the x-axis, label for y-axis is nitrogen content. Then we have the color of the chart will be green. Then we have the spacing between the right top will be 0.6. Then we have the range for the y-axis is 0 to 2.5. 0 to 2.5. So we can put our cursor there and run it. Okay, is here. We have it here. Are we together? Are we together?
Yes, sir.
Okay, good. So we can proceed now to the next thing we are going to do is the next thing we'll do now is t-test. So t-test, this is the first one. We are assuming that the variance are the same. Then this second one, line 24, we are assuming that the variance are not the same. So you know what t-test is all about. So I wouldn't want to go into that. So we'll just run to see what we have. So it's already giving us, look at the p-value, meaning there's no significant difference. Then let's run, okay. This is the p-value, meaning there's no significant difference. What is the implication? Implication mean here is that there's no difference in nitrogen content under base and under sorghum. There is no difference. The nitrogen content in maize farm is the same thing on the soil that sorghum was growing. So can we proceed to correlation analysis? You know, correlation analysis has to do with relationship, the direction of relationship, whether it's a positive relationship or negative relationship, and also the quality of the relationship. So we are on to correlation analysis. So we're just going to run from 26. We'll run. That is the first thing we are doing now is we are running the correlation coefficient, which is 0. My own is giving me 0.1607547. So let's perform the correlation analysis. Correlation analysis. Okay, so the result is there. The p-value means the relationship is not significant because the p-value is greater than 0.05. As depending on what you take as your confidence level. Yeah, level of significance. Okay, so this is regression analysis. Regression analysis, this is the function for regression analysis. This rig 1 is the object. You can write anything. I can decide to write something else here. But whatever you put on the object, when you are summarizing the object, you write the same thing here. Rig 1, rig 1. Okay, so we are going to do a regression for nitrogen and carbon. Okay, so we can run it. Okay, we can also try to see how it looks like. Okay, now let's create the regression line. You can see the regression line here, that red line there. This is the regression line. This is the intercept. So that's that. So now this is multiple regression that's involving two independent variables, one dependent variables and two independent variables. So we are going to see how they relate. While nitrogen, carbon, and pH relate. So we run multiple regression. Okay, so you can see the intercept is there. This is the p-value. Any query? Are we together?
Yes, we are together. We'll ask questions after your teaching.
Okay, good. Okay, so now because we are getting to a close, so the last thing we are going to do is chi-square. Is a chi-square now. So remove the data, store in, and go to import data. The data you import is trigger. We are trying to check the association between overused soil and trigger.
Excuse me, sir.
Okay, go ahead.
This chi-square, are we copying it from the same place we copied the other?
Yes, they are all there. Check after the descriptive statistics, you see chi-square is there. Just copy and put. Okay, let me wait for you for a minute while you do that.
While waiting for her, please, let's go to correlation. Let me ask a question there. Take me to correlation.
Correlation. Okay, go ahead.
Let's go there. Okay, go to your coding on correlation. I want to ask a question there.
Okay, go ahead.
We have nitrogen against cell pH. What if you have other cell parameters, let's say nitrogen, carbon, and you want to run all of them at once?
That is multiple correlation. You can do that as well. So just put a comma and put sort in $sign. That's multiple correlation. So you are fine. You can do that. Please try that on your own. Let's quickly do this chi-square. Let's quickly do this chi-square, please. Have you loaded your data? Your data is trigger. Trigger. Okay. Striker is a very bad way. I think the problem is common in the north. Do we have that problem in the south? Do we have the problem of striker in the south? Hello?
Only in the savannah.
It's not common.
It's common in the savannah.
Okay. It's common in the north. It's very common. It's a big problem in the north. Okay, so we are doing chi-square now. So what we are trying to do, we are trying to check whether there is any association between overused soil and striker. Whether when soil becomes overused and is weak, that is when striker thrive. So that's what we are trying to establish now. So what we are doing now is chi-square test of independence. So first of all, we'll create the contingency table. We're creating the contingency table. We'll run. Okay, the table is created. You can see yes, no, absent, present. So yes, overuse soil. No, soil is not overused. Absent, there is absent of striker. Present, there is present of striker. So let's perform the chi-square test now. Okay, so we've done that. So it's showing us that there's significant difference. That means when the soil is overused, there's tendency for it to be prone to striker infestation. All right. So are we together?
Yes.
Okay, good. Let's do chi-square goodness of fit. So this time around, the data we need is called texture. This is a situation that people expected that the soil texture in Abuja, sandy, silty, clay soil, they are all the same amount. So, but we had to prove that. We had to find out whether what they are saying is true by trying to carry out a chi-square goodness of fit. Where is my texture? Okay, texture. So we are fine. We are fine. So then we go over. We can see our table. Table is there. This is sandy, silty, clay. So we want to check whether these soils are found in the same amount. So we put it on 7. Then we run. So the contingency table has been created. Clay is 18, sandy is 72, silty soil is 40. So let's perform the test. So now we can see that the what the person said, the expected is not true. The expected is not true. So now we can say that we reject null hypothesis that all the soils are the same. All the soil types are the same, texture are the same. So we can accept alternative hypothesis that there is difference in the quantity of sandy soil, the quantity of soil texture in Abuja. Okay. So this is what we did yesterday. And I think we'll just use like 2 minutes for questions. Then we call it a day. Do we have any question?
I have a not question. Hello?
Yes, go ahead.
Okay. Okay, can you share your number if we want to get engaged with you to...
My number is on different documents. Yes, my number is on different documents that I've given you. So let me put it in the chat section now. Okay. My email, my number 08032698736. My email is Andy at gmail.com. Okay, so You can copy from the chat section there. It's also on the PPT that I did.
I want to plead for help on the issue of the video. I was not able to follow up the aspect of the Julius AI because I was having network problems. So I plead that the video should be made ready on time so that one can follow up.
Yes,
really.
Yes, don't worry. It's not from my end. The secretariat, they promised that they will make all the videos ready, but we have to do a little editing. So probably maybe by next week you have it. Please just have patience. Yes, you have it.
Thank you very much.
Yes. But you just mentioned the AI now. Please, I would like you to focus on the AI. Thank you. Any other question or comment or contribution? Why I will leave the floor for the
okay, my own comment is
society.
Thank you very much. You have done a great job here for us. I really appreciate your efforts.
Okay. Thank you, sir. Thank you, sir. Okay, I think at this point I will leave the floor for the society. I believe Professor Jude is still with us. Let me check the comment. I mean, the participant, I believe is still with us. Okay. Professor Jude, Mohammed.
Yes, I'm here, Andy.
Okay, so I leave.
Yeah, thank you. I think I will invite Abubakar, are you around? Is Abubakar here? Vice President, I think you should be on standby because you are the one that will talk. You are the one that will close. But let me see if Abubakar is here because all the energy that went into making this happen came from Abubakar. As a matter of fact, at a point, it was just Abubakar and Andy that were working. Abubakar, are you here? He's not here. Professor Raji, are you here? Prof has gone. So, Vice President, you would speak, but let me give opportunity to maybe two participants to address Andy. After that, then the Vice President will take over. Please, two options. You either jump in or you raise your hand so that you'll be recognized. Anyone is fine.
Good evening to you all. Hello, good evening.
Yes, good evening, sir.
My name is Muhammad Idris, University of Maiduguri, Department of Social Science. So I have to really thank the facilitator for his own wonderful effort. Though I'm used to data analysis, I'm using statistics 10.0 analytical software. So that one is not like an R. So most of the options, the statistical tools are just there. Let it just click and run. So, but with R, I've learned that actually one has to double up. And then when I see this very GLS AI, is the first time I'm hearing about it. And it's a very simplified one. And we look forward to more collaboration with the facilitator. And whenever we need some clarification, we're ever ready to contact him. And we so wish that he will be available for us whenever we need his own assistance. So we have to really thank the society for this. And we thank the facilitator for his tireless effort and for his wonderful contribution. So, my own contribution from my own side. Thank you very much.
Okay. Thank you very much, Mohammed. One more participant, just one more, and if you make it brief, we'll be very grateful.
Hello.
Okay.
Okay. Yes, good evening. My name is Nefer Cable. University of you.
Hello.
Hello, I'm on.
Go on. Go on. Go on.
I also appreciate Mr. Andy. It's not easy teaching adults who are not so familiar with technology. Thank you for your patience. Thank you for taking it through with us. And also want to appeal that please, you should also be available to us wherever we get hooked. Thank you.
Yes, I want to say that Andy is not, you know, I just like him, and his commitment, you have seen it, and even without a lot of commitment from the society, Andy was ready to give all. As a matter of fact, I didn't know that we are following so much because I went to trouble Andy. Andy, you must come back to teach the 4th day. He was on his knees begging that he's traveling and he doesn't want to keep awake tomorrow night. So Andy is available, very, very available. Andy was a soil scientist. I don't know what chasing. It is just because he's looking for money. So our IPP is around. IPP, please, I have called you. I'm calling you again. I give you opportunity to speak. Thank you, sir.
Thank you very much, the Secretary. Like I mentioned yesterday and the day before, honestly, we just want to thank the teacher. I said teacher, not lecturer, because what he put us through in 3 days is like teaching us for a whole semester. I know when you said some people are old and it should be gentle or not, I know you are referring to people like us. But even though some of us are old in the late 60s, I've taken a course in programming using R as a language. But this one he has introduced to me, honestly, is very, 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 very useful. And I'm very sure that most of us, if not all of us, that went through this, I didn't miss any minute, are very, very grateful to him. So what we can do once again is to thank him, because even if he's paid, there's no amount you can pay for this. Individually, you may have to pay over 100,000 to get this done. But how many of us? 50 in the first day, and now we are over 30 here. So we can only thank him for all his efforts and pray that God Almighty continues to bless him with the wisdom and the good health he will need in his future endeavor. We also want to thank the society. Honestly, this is what a society should continue to do for us, so that we don't go stale. Like the man who talked before said, it's used societies. But AI and all these tools are taking over. And the early we get familiarized with it, the better for us as a society. So Abubakar, we want to thank you. Jude, we want to thank you, the VP, and the President himself for making this available to all of us. To all my co-students, participants, I hope we can also share. If the teacher is not available, we can ask each other for assistance. So thank you. God bless. Good night. I think Professor Andy was here. I can't see her again.
All right. Thank you very much, Professor Andy. Please take the floor.
IPP has spoken, and everything has spoken. Every word is correct.
I want you to speak on behalf of the society, on behalf of the president, to close the training.
Okay, on behalf of the president, Jibrin, we want to thank Mr. Andy for your patience and for your kindness, tolerating all our questions and bombardments. We really appreciate you and pray God bless you in Jesus' name. And I will also pass the message to the president to recommend that you he will invite you to give us physical training, regional ones, so that you will register people at Southwest, Northeast, and we have hands-on, because this our language is trending and is good for most of our analytical something, not only for this kind of analysis, modeling, soil mapping, digital soil mapping, is all encompassing. So we need more training, and then we think at the next one, we pray that maybe it will be regional, or maybe in Abuja, as God will help us. I will recommend to the president, maybe we can do more. Thank you so much. And to all participants, I want to thank you that you are really taking time to be available. And I know you shared the message to the rest. My IPP, I thank you. Your support is very good. Anytime I realize you are there, I say, I must also be there. You must have encouraged some other junior ones. If you can be there, I know that there's no excuse for any of us not to be there. We appreciate you. That's Professor Bashir Raji. Thank you. And Dr. Professor Jude, you have done well. You have anchored it well. I appreciate you. Thank you for holding forth. The Lord bless you all. And once again, thank you and good night to everybody. It is well.
Yes. Good night. Good night. Good night. Thank you, Abubakar. Thank you, Akwin. Good night.
We appreciate the secretary.
Thank you for having me.
Night, Prof.
Okay, night.
Thank you.
Thank you.
Thank you. Good night.
Thank you. Get you all.
Bye-bye. My IPP, you are looking so young and you